Hello, in this video I want to show how to measure the shutter speeds of analog cameras, especially mechanical cameras, because there often differs the shutter speeds from the reference values, and so it is necessary to check the correct function. For this I use self-made electronic circuit with a sensor box, you can see, and this electronic test circuit is very simple, and it is portable. It's small, it is portable. And what we need for testing the shutter speed with this circuit is a digital oscilloscope, a digital storage oscilloscope, but there's also possible to use a very cheap one with only one channel. Important is only it is a digital storage oscilloscope. The circuit is very simple. I can show on this diagram. Okay. So there's an integrated circuit with two operational amplifiers. It is a LM358. It's a very cheap one. I only need one operational amplifier. The second is out of order. The most important component of the circuit is a photodiode. I use a BPV21, but it is also possible to use another one. Yes. I use this photodiode in reverse direct. Yes. The cathode is connected with the inverted input of the operational amplifier. The anode is connected with ground. It is also recommended to use the data sheet of the photodiode. There's important information. The back coupling elements are a resistor of 1 megohm and a capacitor of 47 picofarad. The measurement of the oscilloscope is the output of the operational amplifier. Okay. It is recommended to check the circuit before soldering the circuit in a test board. This is a test board, and it is very simple to use. The wire and the devices, electronic devices, can simply be connected. Yes, and there you can check and test the values of the resistor, of the capacitor, if it works fine. Okay, good. This is the test as a test board, the test circuit. It is very small. Yes. These are the connectors, ground and output voltage. The batteries, the switch, and the electronic components. Yes, soldered. And this is the most important part. This is the sensor box. The sensor box. The sensor is put into tube like this. This is a black tube from paper, with paper. The total box is a paper box. Yes, black painted. And in front of the tube there must be a aperture hole like this. You can see this aperture hole, and this is necessary for exactly measuring the shutter speed. I can demonstrate this on this model. I try. Okay, this is a model of a focal plane shutter at slow speeds, slower than the flash sync speed. The first shutter curtain opens completely, and the second shutter curtain closes afterwards. And for faster speeds, the first shutter curtains open, and the second curtain follows before the first curtain completely opened. Okay, and this is the reason why it is necessary to make such a sensor box with tube and aperture hole, because the box, the shutter is in this position open. I try to demonstrate this with the sole. You can see with the tube. Okay, with the tube is here. The shutter is open and is open a little bit, and the tube is here in this position. The sensor doesn't react. The sensor only reacts when the shutter is in the middle. Okay, then try to demonstrate this here. Then the tube and the sensor is open, reacts with light, and if the shutter curtains moves to the end, the tube and the sensor are out of light and switches off. Okay, that's the reason why it is necessary to make a small hole and a aperture tube for the sensor box. Okay, let's try it. I switch on the circuit. I make a reference test with an electronic camera. I use here the Canon T90. I have to put the box behind this shutter, okay, and hold them. I put the box. Okay, I have to open, of course, the lens cap, and I have to make a photo. First, I have to switch on. This is the switch on. Then I have to connect my test circuit with the probe, the oscilloscope probe. I do this here. Okay. Then I switched on the camera. Okay, I take 125 part of a second. I put the box behind the shutter, and then I try to release. The oscilloscope must start. I set the trigger free, and then I try to release, and then we try. Okay, it works. Okay, what did I do? I set the oscilloscope trigger okay, a positive trigger, and the horizontal division is 2 milliseconds per division, and I have 1, 2, 3, 4 divisions. 2 milliseconds is 8 milliseconds. The 8 milliseconds is correct. Okay, let's try again. I reset the trigger here. This is the trigger. Okay, screen. I put the camera in direction to the lamp and release. Okay. Once again, correct. The graph shows 2 divisions are 2 milliseconds, and this is completely correct. Okay. Now I'll try to check a mechanical camera. Okay, first I can try Nikon FM. I try to switch. Okay, it is 125. This shutter speed. I have to remove the lens. Okay. Okay, I have to switch on. Okay, it works. Then I have to open the door. Okay. The sensor box put behind the shutter. Okay, I have to reset the trigger, and now I release. I try to release. Okay, what is the result? 1, 2, 3. Oh, it is a little longer. The time lag is longer than the reference value. It is 8.5. Is 9 milliseconds. Okay, let's try again. Okay, again. Okay, 9 milliseconds. Let's switch faster value. I take 500. 500 is 2 milliseconds at all. Now I can try the right value. 2 milliseconds is I need 500 micro. 500. Now you can see the switch. 500 microseconds per division. I reset the trigger and I try again and release. Okay, what's the value? The value is 1, 2, 3, 4, nearly 5 divisions are 500 microseconds is 2.5 milliseconds, and this is a little too long. 2 milliseconds is a reference value and 2.5 is a little longer, but it's no problem. I accept for my cameras a tolerance of 20%. Okay. I can also try long values. Let's use 2 seconds, a half second, 500 milliseconds. I try to change 500 milliseconds. I use 200 milliseconds per division on the oscilloscope. Okay, let's try. Reset the trigger, and I release. Okay, works fine. What I have 500 milliseconds, 200. Okay, this seems nearly correct. 2 divisions and a half division is 500 milliseconds. Perfect. A perfect value for a mechanical camera. I can also try 1 second. Let's try 1 second. Reset the trigger and I try to release. Oh, I must. Okay, yes. Okay, that's it. We have 1, 2, 3, 4, 4.6 divisions at 200. Okay, is 900. Okay, 900 milliseconds instead of 1000 milliseconds, and it's okay. This is a difference from 10%. It's okay. Okay. This camera seems very good values. Okay. I can try another one. I use here the Pantex Spotmatic 1000. Okay, I can also try 1 second now. It's correct. Adjusted. Okay. Okay. I put the sensor box behind the shutter. Okay, and then I reset the oscilloscope and I try to release. Okay, what's the result? The result is 1, 2, 3, 4, 5. 5 divisions. It's extremely good. It's a correct value. Okay, let's try 125 part of a second. I have to switch to 2 milliseconds per divisions again. 2 milliseconds per division. Okay. I try to reset the trigger and try to release. Hope you can see. Okay, what's the result? The result is 1, 2, 3, 4, 5 divisions. 5 divisions are to, this is 10 milliseconds. It's too long. 8 milliseconds is a reference. Okay. Okay, it's more than 20% difference, and it's more than the tolerance my personal tolerance allows. Okay, I try 500 part of a second. 500, 2 milliseconds is the right value, and I have 2 milliseconds. 500, okay, 500 microseconds per division. Okay, let's try and look if the value is correct. Oh, it didn't release. I must try near the light. Okay, what's the value? The value is 500. Okay, 1, 2, 3, 4, 5, nearly 6 divisions. nearly 6 divisions are 500 microseconds, and this is too much. This is too much. This is 3 milliseconds, and 2 milliseconds is a reference value, and this is too much. Okay, the shutter works too slow at short values, and okay, this is a way to check the shutter speeds. If you have a portable oscilloscope, there are small ones available, and the test circuit is also very small. This is the best thing to check used cameras on the street. Yes, that's it. I hope you enjoyed this video. Goodbye.